Hello everyone. Today I'll be introducing you to our new entity resolution accelerator on Databricks using the securities domain as a demonstration use case. I'll start by defining the requirements of entity resolution, then walk you through the architectural implementation and the capabilities of the accelerator. Before jumping into the demo, a quick word about who we are. At Cavallo Technologies, we are a 100% Canadian Databricks only company. We're a growing team of 60 people with our entire team based in Canada, and we have two offices located in Toronto and Montreal. For the past 3 years, we've been building and delivering high impact data solutions on Databricks across data engineering, AI, cybersecurity, and financial crimes and compliance. We're also proud to be among the top 5 certificate holders in Canada with over 90 certifications, 20 of which are Databricks professional certifications in data engineering and machine learning. So, what is entity resolution? It is a process of identifying and linking records that refer to the same world entity across multiple complex and inconsistent data sources. And the challenge is universal. It appears across several industries where organizations rarely have one clean authoritative source of data for their entities. Data comes in from different systems, each with their own naming standards, identifiers, and data quality issues. This fragmentation leads to a serious business problem. It leads to incomplete views, duplicated records, and inconsistent reporting. We've solved this before in the banking domain by building a customer 360 solution, and without this resolution, organization face regulatory risks, poor decision making, and operational inefficiencies. So what exactly is our accelerator? It is a Databricks native solution designed to unify entities across multiple sources while ensuring data governance, scalability, and explainability. We built it to handle large, complex, high volume data sets where data fragmentation is a real challenge. The goal is simple to provide a single trusted view of entities across complex and inconsistent data sources so that it is ready for analytics. Next, I'd like to jump into the demonstration of the use case. The entire solution lives in this GitHub repository and it's packaged as a Databricks asset bundles, including all the jobs, pipelines, notebooks, and dashboards. By bundling everything together, we ensure reproducibility and consistency across environments. The same bundle can be deployed to dev, UAT, and production environments without manual configuration. Deployment is automated through GitHub Actions and it follows the standard CI/CD processes. As shown in this workflow, the permissions are assigned as part of the Databricks bundle and included as this step over here. Whenever a change is made in GitHub, whether it's a notebook update or a pipeline modification or a configuration change, the GitHub action triggers the workflow automatically. Next, I'd like to show the dashboard that we have created for our use case. This dashboard captures 25 different scenarios that we see occurring in the securities domain. I would like to point out these 25 scenarios occur in less than 1% of the data seen in wild. Over here, we can see the various cases that were resolved by our accelerator, the cases that we missed out on, and we have also provided the provision to manually resolve these cases by incorporating a human in the loop in the system. We can also identify the different entity IDs that were allocated to each of the incoming securities and whether any alerts were generated. Over here, we see an alert generated for quantum motors for data that has come in over the past 2 days. Let's see why these alerts were generated. On day one, our solution wasn't able to capture these entities within the same cluster as we see two different clusters. This also happened because on day one, there were multiple null fields in the identifiers provided by our securities data source. However, on day two, the entities were clustered within the same cluster, and the same entity ID was allocated to both the incoming records. This happened because the incoming data source fixed their identifiers, and now we were able to match the different identifiers coming in from different source systems. Since the entities belong to different clusters yesterday, then today the alert was generated so that a human in the loop can come into the process, verify the newly allocated entity IDs, and confirm whether they were correct or make decisions to rectify that. Going to the job itself, our Databricks job is fully managed by Databricks asset bundles, and it closely mirrors the medallion architecture. The process starts with data ingestion in the bronze layer from multiple disparate systems, followed by transformation and cleaning in the silver layer. All silver data is then graph modeled in the next phase before the data is further curated and aggregated in the gold layer to support the dashboards. This gold data doesn't go without checks. We use the data contract CLI with custom logic to ensure the schema is exactly in sync with the data contract. A data contract is a living contract between data producers and data consumers, ensuring there's no schema drift, data drift, or business meaning drift. For example, looking at the unresolved entity IDs alerts table, we can see how the table aligns exactly with the contract definition. The data contract enforces both schema checks and business meaning checks. Taking component ID as an example, it is mandatory, cannot contain missing values, and represents the unique cluster allocated to each entity. If any of these checks fail, the entire job fails, and the downstream consumption is blocked. In this way, data contracts ensure the data schema and business meaning remain fully aligned. Once the data passes the contract test, it's consumed by the dashboards and visualizations. Since all the tables live in Unity Catalog, we can inspect the metadata, such as the creation date, the owner of the table, and the table properties. We can also view the data lineage to identify the upstream and the downstream tables and drill down to the column level transformations taking place. We can also track insights and data quality trends over time. And that brings us to the end of the operational flow from ingestion to data modeling and governance. To summarize, the result is a fully governed, transparent, and scalable entity resolution system built natively on Databricks. The same architecture can be applied across different industries where the accelerator is fully configurable to client specific rules, data, and domain needs. We also follow the best data practices for governance, performance, data engineering, and DevOps. If you have complex data, this accelerator is the fastest, cleanest, and the most governed solution using the full power of Databricks and design patterns proven over time across industries. Please reach out to us as we would be happy to continue this conversation further. And thank you for your time. See you next time.